Hi, I'm Professor Goins, and in this video I'm going to continue talking about the substitution rule. Substitution rule part 3, where we are going to look at definite integrals. If you happen to watch the first 2 videos, you'll notice everything there was an indefinite integral, so I did not have limits of integration on those. And our final answer always had the arbitrary plus c, so we had an antiderivative and then plus c. And remember that a definite integral represents an area. So we have to have a fixed number as our final answer, which is going to represent area, again, assuming that the integrand is not negative. More about that in another video. But at any rate, the final answer will have a specific number and limits of integration. So let's consider the following integral. From 1 to 4 of x minus 3 squared dx. Now, what this represents is the area under the graph of x minus 3 squared above the x-axis on the interval from 1 to 4. So lower limit of integration, upper limit of integration. So it's the area bounded by the vertical line x equal to 1, x equal to 4. The lower bound is the x-axis, the upper bound is the graph of the integrand. So it's this red region right here. And we don't need to use a u substitution on here, but what I want to show you is how the limits of integration change and why they change. So if I do a u substitution, u would be x minus 3, du would be then dx. When I substitute those in, this would end up being u squared du, which is the integral I have here. And in order to find the limits of integration, well, what happened was, notice the difference between x minus 3 squared and u squared. Well, we could use, since this is a dummy variable, we could write this as, we use a different color, we could write this as the integral of x squared dx. Again, it's a dummy variable. So the difference between x minus 3 and x here is a horizontal shift, which means I shift the graph. If I go from here to here, I shift 3 units to the right. So if I go in the reverse direction, I shift 3 units to the left. So let's take a look at, if I take this graph and shift it 3 units to the left, the vertex is going to go over to 1, 2, 3. So that's going to go over to the origin. And that means my graph is going to look like this, or the area that I have here. And this portion here is going to go 2 units to the left of the origin. So that's going to go back here, and it's going to go up 4. So back to up 4 would put me about right there, which means my graph would look like that. And if you look at the area bounded by the curve in the x-axis, if I just shift the whole thing 3 units to the left, my new region of integration is bound between -2 and 1, which means my new limits of integration are from -2 to 1. Then we would integrate this and use those 2 values as our evaluation as my last step. But certainly we're going to get some integrals that are significantly more complicated expressions and more complicated graphs. And the fact that this is a linear substitution makes things a little bit nice in this case, but it provides, I think, a good visual. What I want to do is show you how to come up with the new limits of integration if I don't want to graph this, or if it's not convenient to graph. And certainly it's more efficient not to graph. So let's take a look at finding the new limits of integration. And let's use this specific example since we see reasonably with what it should be. What I'm going to do is, so I'll say, for example, again, I'll just copy down the same integral, so 1 to 4, x minus 3 squared, and then dx. When I do the substitution, I would have u is x minus 3, du is dx. So new variable, new differential, now let's do the new limits of integration. And the way I do that is the original lower limit of integration. So the lower limit originally was x is equal to 1. So then what I do is I'm going to find the corresponding u limit of integration. Well, I know u is x minus 3, and x is 1, so this is 1 minus 3, which would be equal to negative 2. So my new lower limit of integration is negative 2. Of course, that's what we have over here, right? It should match. And then for the upper limit, originally the upper limit of integration was x is equal to 4, and then when I substitute that into this right here, I get u is 4 minus 3, which is 1. So my new upper limit of integration would be a 1, and again, u squared du when I substitute in the new variable and the new differential. And then this, to complete that off, you would evaluate the, well, we might as well just go ahead and do it. When we finish this off, this would be u to the third over 3 from negative 2 to 1. And remember, when we evaluate an antiderivative by computing an integral, we evaluated the upper limit of integration first. So 1 to the third over 3 minus negative 2 to the third over 3. So I've got 1/3 minus minus a plus 8/3, 9/3, which gives me